Hello everyone. Welcome to the solution of LeetCode problem 1026 named Maximum Difference Between Node and Ancestor. In this problem, we are given a binary tree and we have to determine the maximum difference of any node with any of its ancestor value. So here, let's consider this first example. Here the root is 8, which has two children, 3 and 10. 3 has two children, 1 and 6. 6 has two children, 4 and 7. 10 has one children, 14, and 14 has one children, 13. So here we can see that the root is 8 and one of its descendant is 1. Or we can say that for this one of its ancestor is 8. So the difference between them will be 7. And we can see that for any of the two pairs of ancestor and descendant, this difference 7 is the maximum. So here we have to return 7. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to understand the algorithm, we have taken this example. Here the root is 8, which has two children, 3 and 6. 3 has one children, 1. 6 has two children, 7 and 4. Now the problem is, how can we solve this problem? Basically, we have to solve this problem by using the DFS function. And here the basic principle is inside each of the node or inside each of the DFS call, we will store two values. One is the maximum and another is the minimum. Why? This maximum value represents the maximum value from root to this node. Suppose currently our node is 1 and this minimum value represents the minimum value till root to this node. So initially our call starts from root 8. Here for this root 8, the maximum is 8 and the minimum is also 8. Okay. Now from 8, we will go to the node 3. Now for this node 3, the maximum value in the path from 8 to 3 is 8 and the minimum value is 3, which is this node. Now from this tree, we will go to the node 1 and here the maximum value will be 8 again and the minimum value will be 1. Now from this 1, as this 1 is the leaf node, we will return. Now from 1, we will return the difference between 8 and 1, which is 7. Now, what basically this 7 represents? This 7 represents the difference of the maximum value and the minimum value along this path. Now the value 1 represents 7. So from 3, we do not have any of the right children. So here 3 will return the maximum of 7 and 0. And if the 3 have the right children, it will return 0. So here 3 will return the value 7. So it is returning the value 7 here. So far so good. Now from the node 8, we will go to the node 6 and here the maximum value is 8 and the minimum value is 6. And from this node 6, we will go to the node 7 and here the maximum value is 8 and the minimum value is also 6. So here from this 7, we will return the difference between 8 and 6, which is 2. What these two basically means? These two basically means the difference of the lowest and the highest node along this path. Now from this 6, we will go to the node 4 and here the maximum value will be 8 along this path and the minimum value will be 4. And this 4 will return the difference of maximum and minimum, which is 4. Now From these 6, it has 2 value. From 2 from the left subtree and from 4 from the right subtree. And it will return the value, the maximum of 2 and 4, which is 4. That means this 4 basically denotes that this path is optimal, because here the difference between the maximum and minimum is maximum. So here 6 will return the value 4. Now 8 is receiving two value, 7 and 4. So it will return the maximum of 7 and 4, which is 7. And this 7 basically represents the difference of this node 8 and this node 1. And basically, that's how we're going to solve this problem, by using the depth first search algorithm. And the overall time complexity of this algorithm is big O of n. And also, overall space complexity of this algorithm is big O of n. I hope you understood the algorithm. Now let's move on to the code. Here in the code, we are given a function named max ancestor difference, which is a root as a parameter. Now insert this, we are calling a recursive function named DFS with the root value and maximum and minimum value, and maximum and minimum will be initialized with the root value. Now inside the DFS function, if root is null, we have to return the difference between maximum and minimum. After that, we have to upgrade the maximum and minimum value for each of the root. Then we have to recursively call the DFS function into the left subtree and into the right subtree with this maximum and minimum value. After that, we have to return the maximum of the left and right subtree value. Finally, the return value of this DFS will be returned. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.